Hello everybody, Kody Newman here, and today I'm going to be giving a quick tutorial on how to do manual denoising in the iSyncBrain online platform. For those who don't know, iSyncBrain uses Adaptive Mixture Independent Component Analysis, or AMICA, in order to automatically clean or denoise the data. It does this by separating the 19 channels of data into 19 independent components. These components may have to do with brain data or artifact. We then have an AI system that goes in and knows which components are real brain data and which ones are artifact that can be removed. This AI algorithm usually works very well, but occasionally it can make mistakes, so it's important for you to know how to go in and fix it when a mistake may happen. And that's what I will be showing you guys today. So for this example, we're going to be looking at this file. Here at the top of the report, you can see our raw data, quite a few artifacts in this eyes open data, but this is the clean data where the AI has come in to denoise. What you may or may not notice though is that T6 and a little bit at T5, but mostly T6 is a little bit louder than the rest of the channels and has parts of it without phase or field, showing that there's some sort of artifact data here. And sure enough, if we go down to our absolute power charts, you can see the T6 electrode has a lot of power and is kind of taking up most of the power, especially in the delta and theta bands. This is due to a faulty or loose electrode connection. You can sometimes see it like this, where it'll look like a target taking up all of the power in all of the different frequency bands. That's one of the main types of artifact that needs to be removed. Another type of artifact you may find is cardioballistic. So if you look at your power spectrum, by clicking on one of these spectrums down here, you may notice a peak in the delta to theta range. This, if it's around 3 to 6 hertz, may be cardioballistic in nature. Basically, the electrode is on a blood vessel, and as your heart pulses, it moves that electrode and we pick up the signal. Another common type of artifact is going to be eye movement. You'll usually see that in the delta and theta bands right near the front of the head, or beta bands if it's more of a twitch or more extreme eye movement cases. And the last component that you may often find is EMG, basically muscle artifact through a tense neck, tense jaw, or tension in the forehead. Basically, any muscle is going to be a lot louder than EEG and will get picked up by the system. So you look at your report and you think that there is some sort of artifactual data. How do you go about manually denoising it? So all you have to do is navigate to the portal.isyncbrain.com platform, go to EEG processing, individual analysis, and then select the box next to the data you want reanalyzed. Then up here at the top right of the screen, there's a reanalysis button. There may be extra charges using the reanalysis based on your subscription. Here you can select either auto denoising, so this will just give the AI another chance, or manual denoising, which is what we will be going over today. You're going to want to reselect the new ICA components, and then we also have this signal restoration algorithm. The basic idea of this is that if you have 1 to 2 faulty channels with really loud artifact data, this algorithm will go in and clean just those channels for you by averaging the data from the rest of the signal. In our situation, we don't have this, but it can come in handy for messier data. So once you're happy with your selections, you can go ahead and hit confirm and confirm one more time. It'll then take about 5 to 10 minutes to process, and then you'll see this reanalysis number report at the top of your individual analysis screen. Eventually, it'll say ICA in the progress section, and you can go ahead and click view on the right to view the result. And that'll take you to this page. So on the ICA selection page, we have 4 sections: the raw data, the component data in time series format, the component data kind of in more of a deep analysis, and then our clean data at the bottom. So our raw data is just that. It's the data that's already been bandpass filtered, but basically the raw data from the device. And then we separate that into those components. Note that over here on the left-hand side, we have the number of the component instead of the actual location. So instead of FP1, FP2, we have numbers here. Now, a good way of seeing what a component is if we look at our raw data, you can see these eye blinks taking up a lot of the frontal channels. You can see it right before the 2-second mark, the 5-second mark, 10-second, 13-second, etc. And you can see that these components, or this eye blink is taking up multiple channel locations, sometimes all the way back to the posterior electrode spots. But in our component time series data, you can see that this actually just takes up one component. So this component is over a large area, but it is just the eye muscle and eye blink artifact being removed. So when you're actually going in to remove or manually select new data, you're going to pay a lot of attention to this time series and to this component data chart. So if we click on this gear icon in the top right of the screen, you'll see all of the ICA components. The ones that are highlighted in blue and already checked are the ones that the AI checked as artifact. And now we're going to go in and add more or remove them as we see fit. So starting with our component number 1, we can see here that this is the one at T6. You can tell it's artifact based off a few reasons. 1, it's only at one channel location. 2, it has a ton of power, way more power than is normal. Generally, you won't see anything above 100 unless it's artifact. And 3, at our source location, you can see it's locating it off the skull, not in the brain. For all these reasons, and the fact that if we look at the actual raw time series data, component series data, you can see all of these large bounces and spikes. And if you're curious, you can check, for example, at the 34-second mark, we can see these 2 large hills. And if we go to the 34-second mark in here, you can see those hills are only at T6. There's no phaser field. This is indeed artifact data. So for those reasons, we will check it as artifact. Now we can continue. Artifact number 2, very similar, less high in power though, and it's only at this one location on the temporal lobe. Now if we look at component number 2, you can see it's kind of a darker tracing, and what it is it's that T3 EMG muscle tension. We can see at T3 and T4, these darker tracings are due to there being some muscle activity, much faster than the brain, and no phase or field. You can also see in the power spectrum, it has a lot of high frequency values above the 1 microvolt squared. So this was correct to remove as artifact. We don't want jaw muscles, we only want brain data. Next up is number 3. This is pretty classic eye movement artifact, vertical eye movement or eye blinks. We can see in the power spectrum, it's really high. It's only at the front of the head, and it's being source located right in between the eyes. So this is eye blink artifact. It is correct to be removed. 4, we've now gotten to some real data. We can see an alpha peak here. There is some slow activity, and generally for alpha peaks, it may look like it's on the surface, but that makes sense just based on the generator. This looks to be real brain data, so we will leave it. Number 5, very similar, just that occipital alpha peak frequency on the right hemisphere. Component 6, this is that jaw tension on the opposite side on T4 that was spotted by the AI and already removed correctly. Again, notice that it has a lot of power in these higher frequency bands, and it's just a very jagged and small tracing and located right on top of where that muscle would be. 7, we're looking at another loose electrode contact. It's really high in amplitude. It's only in that slow band, and it looks like a target at one electrode site. So this is correct to remove. Now we have 8. Now this one is throughout the head, but notice the interesting power spectrum, a bunch of recursive peaks. And if we look at the time series data right here at the top, you can see a slow bounce going at about 2 hertz. This is actually going to be heart rate artifact or cardioballistic artifact. When, as I mentioned, when an electrode is on a blood vessel and the heart is pumping, the electrode will move a little bit and get a little bit of electrical activity picked up. and that's what we see here. So 8 is actually artifact that we want to remove. Next up, 9. This one also looks to be a little bit artifactual. You can see that slow bounce. It's something to do with the blood, and you can see that peak on the slow side and the fact that it's on the surface. It could be said that there is some real data in here based on these small little bounces in the back, but they're so low in power that I am happy to say that they can still be removed. You might want to further investigate this by looking at the Brodmann area for this region, or if you know what is going on clinically with the subject, you may expect to see something like this, but for this subject, it doesn't really make sense and is therefore likely artifact. So now as we continue, we're going to have a lot more real brain data. And what pattern you may have noticed, if we compare, for example, this artifact or component 10, to component 1, it has a lot less power. As we go down these components in the list, we're going from more to less power. And that's how they're organized. So it becomes less important as we go down to know which ones are or are not artifact, and also more difficult to find out. So for this one, there's some slow activity, some activity in the alpha and beta bands, but generally it looks pretty real, so I'll keep it. And I'm just going to kind of zoom through these last few. 11, this looks like real data. 12, likely real. Again, notice they're really low. This one is going to be some sort of cardioballistic based on this recursion pattern, kind of all over the head. And you can kind of see that it like spikes down again every 2 seconds, very similar to the other cardioballistic artifact we had. 14, this is classic horizontal eye movement. It's going to be opposite on either side, but again, only at the front of the head. You can see the blues, which means a lot less activity versus the right. This is always going to have one be red and one be blue. This is just horizontal eye movement and therefore should be marked as artifact. 15 we'll say is real. 16 looks real enough. 17, 18, and 19. 19 usually is just everything left over. You'll notice the power is extremely low. We are getting some line noise here, these kind of recursive peaks, but it's nothing that's going to be taking up a lot of the data. And generally, you don't want to throw out too much data. Don't want to throw the baby out with the bathwater. So I would keep a 19th component generally. You're really just looking for the components that are having a large impact on your data quality. If it's not having an impact, it's not really causing any issues. So now on the right, we can see we've selected 7, 8, 9 components. Generally, I recommend only selecting 10 or less. In a good recording, you should only need to select about 5 for eyes open, maybe 2 or 3 for eyes closed. It really just depends on the recording quality. But once you're happy with the components you selected, you can hit the preview button on the right-hand side. And the loading screen will come up for a second. And then it takes a second to update the actual chart. So pay attention to T6, see how we still have all that noise, and then watch what happens once this eventually decides to update. This is just a visual glitch. It is actually processed. It just takes some time for us to catch up. And there we go. T6 now looks a lot more normal. Everything looks larger because it's no longer trying to match how large T6 is, and we have some real brain data. Once you're happy with your clean data, you can go ahead on the side and hit the post-processing button. Similarly, it'll have a loading screen for a little while, and then a second loading screen, and eventually we lead to this clean data page. So what we can do here now is time series rejection. So if we click on the gear icon, we can see a little section for start time and end time and a reject button. So this is for artifacts that only happen at one point in time that you want to remove for that point in time. So going through the data, there's nothing too clearly artifactual that's standing out still. We did a pretty good job with removing artifacts. I'm generally looking for something that doesn't have any phase or field. And for example, I'm looking right here at the around 61-second mark, and there's a little downward facing spike that is not matching up with anything else in its location at F4. So I'm just going to remove that time series. So I type in 60 seconds and I'll go from 60 to 61 seconds, hit reject. And then once that's finished, you can hit final analysis. This takes about 5 to 10 minutes to process. Once you've hit that final analysis button, it's just a waiting game. You can go ahead and close out of this window, and eventually on the browser here, this will switch from ICA to completed, and you can view the results. And again, if you're happy with the results, you can go ahead and check this box and add any of the other reports you like, such as the normative, the clinical biomarkers, the summary report, or the 3D views. So that is how to do manual denoising in the iSyncBrain platform. Thank you for watching.